edge with arrows on either end. 3. Same steepness, parallel lines. Hand drawing is mostly parallel, yeah. Technically parallel. By hand, we want to be as precise as we can, but okay. So let me put these down too if there are any questions on these. And now these on each are separate just to really compare when you see slopes, what you can expect. So we've got y equals 1/3 x minus 2 and y equals negative 3x plus 4. But any questions on these top ones? Now there's the other pretty form I'm going to show you if I can right before we leave, which you can also easily graph from. But you read it, it speaks a slightly different language, but it tells you the same information. But you want to be able to look at either form and go, oh yeah, I can graph that. I'm going to find both intercepts and the slope. And you can even see here too as a check. You know this one, if there's no b, it goes to the origin, so that's both intercepts. Here, if y equals 0, then I just subtract 3 from both sides and x equals negative 3. So my x-intercept should be negative 3. This one is a little easier to do mentally. You got more stuff going on. Actually write in 0 for y and solve for x. But here you can see, oh, if y is 0, subtract 3 from both sides, x is negative 3. So that's this line right here. Check. It goes through negative 3 on the x-axis. Okay? Hand graph might be slightly off. Is that a fraction? No. But as long as it's not over here, you know you're on the right track. Here, if y is 0, I would add 5 to both sides, and x would equal 5. That's this line here. And yeah, it crosses at 5 on the x-axis. Okay? So it gives you an extra check. Okay? What's my y-intercept here? And my slope? Now that's either up 1, 3 to the right, or down 1, 3 to the left. It's either 2 positives or 2 negatives. You can go in both directions because it's a positive slope. Negative 2. Now before I even draw it though, I'm going to visualize. Positive or negative slope? Right. So I'm expecting an, well, that is positive makes it upward or downward? Upward. So there's 2 things you can check on the slope, positive or negative. Positive means it's upward. If it's a diagonal line, positive means upward. The other thing you can check is whether it's steep or shallow. That slope, the absolute value, regardless of whether it's up or down, the absolute value of that slope is less than 1. Makes it a, right. Now this one, upward or downward? Steep or shallow? Steep. Right. Even though it's negative, the absolute value, 3, is greater than 1. Okay, so that's steep. So we're expecting a steep downward line here and a shallow upward line here. As soon as you visualize that, you can catch yourself when you graph it and catch careless mistakes. So go up 1 over 3, and I'll do it one more time just to be super accurate. And I check, yes, upward, shallow line, just like I expected. It's going through negative 2 on the y-axis. Done. And here, I've got 0, positive 4 with a slope of, now if your slope is a whole number, just put it over 1. I can do negative 3 over positive 1, or I can do positive 3 over negative 1. If it's a negative slope, it doesn't matter whether, for counting purposes, you put the negative on top or the bottom. Just one or the other. So if I start at positive 4, and then I'll do both. I'll do a negative 3, 3 down, and then 1 to the right, positive 1 to the right. I'll go back where I started, and I can also do 3 up, positive 3 up, and negative 1 to the left. and you'll see it all falls on the same line. There's a negative slope, downward line, and it's quite steep. Okay? So I make that visual check before I commit to drawing the line. Is that okay? Okay. Last part would be a little rushed. I was in my other class too, but I was able to cover it, so I want to just keep us on the same track. So let me introduce this last form. Any big confusions here or anything? Are we? Okay, so definitely talk to me after class, and from 12 to 1, right after class, noon, I'll go downstairs for the open lab for anybody who wants to come down and work in there. Okay, so just to finish up here, this is one of our pretty forms, the y equals mx plus b, and the slope-intercept form, and the other pretty form is this. Let's take our y equals 2x minus 8, and I want you to put the x, the 2x, over on the left, okay? And any constants need to stay on the right or be moved over to the right. So move both variables to the left and all the constants to the right. Okay. Move variables left and constants to the right. Okay. Depending on what you're starting with, you may have to do more movement or not very much. In this case, I'm just going to have to do minus 2x on both sides. It cancels it out there. These are unlike terms, so they can't be smushed together, but just make sure and put them in alphabetical order. And mind their signs. This is a negative 2x plus y equals negative 8. Now, Math Lab isn't picky about this. Not everybody is, but I am. Is that you cannot have a leading, for it to be true standard form, as I'm showing, it should not have a leading negative. Doesn't matter if the y and the constant are negative, but the x should not be negative. Is it legal for me to turn negative 2x into positive 2x?
No.
Yes, if. Right. And not just the other side, but when you're using the multiplication rule, or the multiplication/division rule, with addition and subtraction, think of it as adding or subtracting the same thing to both sides. With multiplication or division, think of it as being fair to every term, just like when we kill fractions or decimals. Do the same thing to every term. You can flip a sign just by multiplying times negative 1. Negative 1. Okay? So as long as I multiply every term by negative 1, then it's fair. Okay? That's our multiplication property. This is the same thing I would do to kill fractions. But it's not an LCD. In this case, my goal is to flip that first sign. Now, as you understand that principle, you don't really have to write that under there. Just think, oh, I don't want that leading negative. I'm going to change it to a positive 2x, and that's fair. Remember, multiplying by negative 1, all that does is flip signs. So that makes this positive y and this negative 8. Yeah. So this is the form ax plus by equals c. Now note how the a, b, and c are capital letters. They're specifically capital because that tells us that a, b, and c are integers. I use the capital letters to imply integers. Not just, that means no fractions or decimals. If there were any fractions, or if you're changing like from slope-intercept form to standard form, if there were any fractions here, the first thing you do is kill the fractions. Just like as if you were solving a fraction equation. You're not solving, but you'd use the multiplication property, multiply everything by the LCD, kill the fractions, and then move things around. Okay? And we'll be doing this more, especially on the last day of the unit when we are writing our own equations, and we may have to change from one form to another. But the idea is that a, b, and c are integers, and me specifically, picky, a should be greater than 0. Math Lab will not be picky that way, but I am. So just use it. They'll accept both answers on my Math Lab, so you can get in that habit. Okay, so this is what's called standard form of a linear equation. And that standard form tells us 3 things, just like the slope-intercept form. Slope-intercept form, without any math, tells us the slope and the y-intercept, and with a little bit of math, plugging in y and y equals 0 and solving for x tells us the x-intercept. Those 3 pieces of information, all we need is 2 of them to graph a line and the third to check our work. And we can get the same information out of a standard form equation too. And this is how we find it. I'm going to use this as an example, the 2x minus y equals 8. Now the very definition, the easiest way to graph, you're given this, one way is to solve it for y and then use the slope-intercept form to graph it. Okay? Another way is to just, hey, it's a standard form, I can graph this with my intercepts. Just like slope-intercept, finding the slope and the y-intercept is the easiest way to graph it. With a standard form, the easiest way is to find the 2 intercepts. And because it's in this particular form, this is how we can find the x and y-intercept most easily. I know we're pushing the time, so I know in like, it is, yeah, that clock's a little off. Because I want to finish this recording for my online students, I'm going to go ahead. If you can stay another 3 minutes, that's great. I understand if you can't. But we'll definitely pick up from here next time. But if you can stay another 3 minutes, that's awesome, because I'm right at the end here. I do want to continue for the recording. All right, so x is 0 and y is 0. That's the definition of intercepts. And when it's in this form, we can use something called cover-up, which is just a quick little way, a quick, efficient way to basically plug in and make a table of values without it being all messy and ugly. So plug in for intercepts. Cover up for intercepts. Okay, so if x is 0, what happens to 2x?
Y is 0.
Poof. Well, no, not y isn't, but if x is 0, yeah, if x is 0, 2x goes away, right?
Yeah.
So we cover it up. Don't cover up the negative. You cover up the 2x and you write down what you see. Negative y equals 8. And now the most you have to do is, in this, you have to solve for y. So if y is negative, multiply both or divide both sides by negative 1, and you get y equals negative 8, just like we knew from the slope-intercept form. So there's x equals 0 and y equals negative 8, and that is your y-intercept. Okay. Now if y equals 0, well, that means the y goes away, because minus 0 doesn't change anything. So cover-up just says, hey, if y equals 0, the definition of the x-intercept, poof, it's gone. It doesn't matter whether y was positive or negative, it's all gone. Write down what you see. 2x equals 8. Most you're going to have to do then is divide away the coefficient, and x equals 4. Hey, exactly like we expected. This is 4, comma 0. Y was 0, so x is 4, and that is our x-intercept. Oops, there we go. And the one other thing you can find to either check your work, or if one of your intercepts is a messy fraction, harder to hand graph, then finding the slope is very useful to check your work and also to help you graph. This is how we find the slope. If I take ax plus by equals c, and I'm going to solve for y, I'm going to change this with no numbers, with letters, into slope-intercept form. That means I'm going to do minus ax on both sides, and I get by equals negative ax plus c. Divide away the b from every term to be fair. And that gives me y equals negative a over b. I pull it out as a fraction coefficient of x plus c over b. Now that looks a lot like slope-intercept form, right? But instead of writing m, what do I have? Negative a over b. Now it's negative because when I changed it from one form to another, that ax had to move to the other side, so it became negative. In slope-intercept form, the slope m is exactly what it is. If it's positive, it's positive. If it's negative, it's negative. Don't change that. In standard form, you can take standard form and just put the a over the b, but then you flip the sign, and you have the slope. Okay? What this tells us when I solve for y here is that right there is m. So if you want to find slope from standard form, your slope is equal to put your a over your b and flip the sign. Don't flip it in slope-intercept form, but in standard form, just take your a over your b. So look at this. What's my a? My a is 2. So m equals negative a over b, which means negative. I just put the negative sign. My a is 2, and what's my b?
1. We might have 1.
Negative 1, right? Okay. And so it was negative as part of the formula, positive 2 over negative 1, which makes my slope what? Positive 2, which is exactly what we knew it was. Okay. So that's it. From standard form, a quick way to find slope. Just take that a over b and flip the sign. Just mind your signs on that one. Okay. All right. Sorry for going over a little over there. Yeah, do 8.1, read ahead in 8.2, and like I said, we'll do more of this sort of working with the equations and graphing practice into next week as well. Okay? And I will be downstairs at noon if anybody's staying for the lab. Do make sure and return the rulers up here, please.